factories turn tons of raw potatoes into perfectly ridged Ruffles chips in a matter of minutes. And the process is way more complex than you think. Blades slice at blistering speed and precision seasoning hits every chip with mechanical accuracy. In this documentary, we go inside the high-intensity world of Ruffles production to see how one of America's most iconic snacks is made from start to finish. The manufacturing process for Ruffles potato chips begins long before a potato even enters the production facility. It starts with agricultural planning and controlled sourcing. Ruffles, as a brand under Frito-Lay, utilizes proprietary potato varieties that are cultivated specifically for chip production. These aren't the same types of potatoes used for baking or mashing. Instead, Frito-Lay contracts with dozens of partner farms across the United States and other regions to grow chipping potatoes, varieties like Atlantic, Snowden, or proprietary Frito-Lay hybrids that are selected for their specific characteristics: high dry matter content, low sugar levels, uniform shape, and dense texture. Each crop is grown with tight controls on irrigation, fertilizer use, and harvesting schedules to ensure consistency and minimize storage degradation. Potatoes that are too moist, sugary, or irregular in shape would result in chips that are oily, dark, or fragile, none of which meet the Ruffles brand standard. At harvest, potatoes are collected using automated harvesters equipped with rubber conveyors that minimize bruising. They're loaded into transport trucks and sent to the factory, often within a few days of being pulled from the ground. When the potatoes arrive at the processing plant, they enter the facility through the raw receiving bay. These are enclosed intake areas where truckloads are weighed, logged, and tested before being accepted for processing. At this point, technicians from the quality assurance team extract random samples from the load to check for size uniformity, sugar content, starch levels, and moisture content. Any batch of potatoes that falls outside the tight specification window may be rejected or diverted to other non-chip product lines. Once cleared, the potatoes are offloaded from the trucks into a large receiving pit, essentially a hopper connected to a series of conveyor belts. From here, the potatoes are moved toward the initial cleaning phase. This begins with the de-stoning drum. As the potatoes enter this large rotating cylinder, jets of water and the rotating action cause heavier materials, like rocks or clumps of soil, to separate and fall through grated bottoms. Potatoes are lighter and are lifted to the next stage. From the de-stoning drum, the potatoes enter the pre-wash flume system. A flume is a water-filled channel that moves product gently using the flow of water instead of belts. This minimizes physical damage to the raw potatoes while removing dirt and loose debris. The flume water is treated and recirculated through industrial filters and chemical dosing systems to ensure both sanitation and water conservation. In many modern plants, the water used in these systems is part of a closed-loop recovery system designed to reduce environmental impact. The next stop is the rotary scrubber. This is a long, cylindrical machine fitted with internal brushes that rotate as the potatoes pass through. High-pressure nozzles spray water as the tub rotates, scrubbing away any remaining mud, sand, or biological debris. The inside of the scrubber is lined with abrasive surfaces that help clean the rough skin of the potato without cutting into the flesh. The goal here is to deliver a clean, undamaged potato with its skin still intact, ready for inspection. After scrubbing, the potatoes are lifted out of the washer by a cleated incline conveyor and passed through a visual and automated inspection system. In this phase, both human inspectors and camera-based vision systems work in parallel. The conveyor belt is engineered to spread out potatoes into a single layer, and each tuber moves past a combination of high-resolution cameras and infrared sensors. These systems are trained to detect green spots, bruises, cuts, or signs of rot. Any substandard potatoes are rejected via automated diverter arms or air jets, which remove the faulty items from the belt and send them to waste or compost streams. Human operators stationed along the line also remove visibly defective items that machines might miss, such as those with odd shapes that won't slice well on the crinkle-cut blades. Every removed potato is scanned and logged into the factory's waste tracking system, allowing operators to identify trends and address upstream sourcing problems if too many rejects appear from a single truckload. Now that the potatoes have passed visual inspection, they move on to the peeling station. For Ruffles, peeling is essential. While some gourmet-style chips retain their skins, Ruffles chips require a smooth, peeled surface to produce clean, consistent ridges during slicing. Peeling is achieved using a combination of steam and abrasion in what's known as a steam peeler. The steam peeler is a high-pressure vessel that receives a batch of potatoes, seals the chamber, and subjects the potatoes to pressurized steam, usually around 180-220 psi for 8 to 20 seconds. This superheated environment rapidly loosens the outer skin layer by partially gelatinizing the pectin between the skin and the underlying tissue. Once the steam cycle ends, a sudden pressure drop causes the skin to puff and detach slightly from the flesh. Immediately after this, the potatoes are discharged into an abrasive roller peeler. This is a rotating drum lined with rough surfaces, often embedded with carborundum grit, that gently scrubs the now loosened skins away. Water sprays are used to flush away the skins and clean the exposed potato surface. The amount of skin removed is carefully monitored. Too much abrasion would remove usable flesh and increase waste. Too little would leave patches of skin that affect the slicing process. The peeled potatoes are rinsed again in chilled water to stop any residual thermal activity and prevent enzymatic browning. A small dose of food-safe antioxidant, like sodium metabisulfite or citric acid, may be added to the rinse water to preserve the pale color of the peeled surface and prevent discoloration before slicing. At this stage, the potatoes are fully clean, peeled, and ready for their signature transformation, being cut into the iconic ridged slices that define a Ruffles chip. With the freshly peeled and rinsed potatoes now ready for transformation, the next phase in the Ruffles production process focuses on slicing, the moment where whole tubers are precisely cut into their distinctive ridged form. The ridges are far more than a visual or marketing detail. They play a critical role in the chip's strength, texture, and frying performance. This stage involves advanced slicing technology, careful temperature and starch control, and continuous monitoring to ensure each slice is the exact thickness, shape, and structural consistency required for optimal cooking and crispness. The peeled potatoes are transported to the slicing area via gentle, water-based flumes or soft conveyor belts to minimize impact and prevent bruising. Once they reach the slicing units, the potatoes are fed one by one into high-speed rotary slicers designed specifically for crinkle or corrugated cuts. These industrial slicing machines use a rotating impeller or feed wheel to press each potato firmly against a stationary, razor-sharp cutting head fitted with ridged blades. The blades are precisely machined to form a consistent wave pattern, typically with a wave amplitude of 1.5, 2.5 mm and a thickness of around 1.3, 1.5 mm. Unlike flat chip slicing, where a smooth blade is sufficient, Ruffles require a carefully engineered ridged blade made of hardened stainless steel. These blades are aligned at specific angles to produce even, undistorted waves along the chip's entire surface. The sharpness, speed of rotation, and pressure exerted must be perfectly balanced. Too much force or misalignment can result in chips with uneven ridges or broken tips, which would either fry unevenly or be rejected later during inspection. The sliced potatoes are ejected from the slicing drum at high velocity and collected in a shallow trough or on a belt that immediately begins the next critical step: starch removal and surface moisture control. Every potato contains natural starch, and when sliced, a large amount of that starch is released onto the cut surfaces. If not removed, This surface starch can interfere with the frying process, causing chips to stick together, fry unevenly, or develop burnt spots. It can also result in a greasy or gummy mouthfeel, which is unacceptable for Ruffles' clean, crisp texture. To remove excess starch, the slices pass through a multi-stage rinsing system. In the first phase, they enter a flume filled with cold, recirculated water, where they are gently agitated to dislodge free starch. The water in this flume is constantly filtered and monitored for starch content, with automated control systems adjusting flow rate and replacement intervals to maintain effectiveness. Following the first rinse, the slices often move through a series of cascading rinse curtains, sheets of filtered water that fall like waterfalls over the slices as they travel along a mesh or perforated conveyor belt. This helps remove residual starch without applying any mechanical force that could break the delicate ridges. After rinsing, the slices must be dried to a specific degree, not fully desiccated, but dry enough on the surface to allow the hot oil in the fryer to crisp the exterior without creating steam pockets or excessive foaming. This is achieved using a dewatering shaker and an air drying tunnel. The dewatering shaker is a vibrating belt or tray that shakes the slices gently to remove bulk water. The slices then pass under high-velocity air knives, rows of precisely aligned jets that blast room temperature or slightly warmed air across the chip surface. The air knives are tuned to create a shearing effect that strips away surface moisture while maintaining the shape and integrity of the ridged cuts. At this point, the slices are considered ready for frying, but only if they meet one final set of pre-cook inspection criteria. Before entering the fryer, the slices pass through an optical sorting system. This state-of-the-art inspection station uses a combination of high-resolution cameras, infrared sensors, and sometimes laser scanners to detect defects such as green spots, bruising, overly large slices, or broken pieces. Defective slices are rejected with microbursts of compressed air, which knock them off the main conveyor line and into waste or reprocessing bins. The acceptable slices, meanwhile, are evenly distributed across the width of the fryer in feed conveyor to ensure uniform exposure to hot oil. Frying is where the raw slices become what we recognize as potato chips. And for Ruffles, this step is both art and engineering. The chips are fried in continuous fryers, long stainless steel troughs filled with high-temperature cooking oil. The oil is typically a carefully formulated blend of vegetable oils, often including sunflower, corn, or canola oil, chosen for their high smoke points, neutral flavor, and oxidative stability. The oil is filtered, treated, and replaced on a tightly regulated schedule to maintain quality and avoid flavor degradation. As the slices enter the fryer, they are immediately submerged by a submersion conveyor that ensures they stay evenly beneath the oil's surface throughout the cooking process. The oil is maintained at a precise temperature, usually between 170 degrees Celsius and 190 degrees Celsius. This range is critical. Too cool, and the chips absorb oil and turn soggy. Too hot, and they brown too quickly or develop burnt notes. Each chip is cooked for approximately 2 to 3 minutes, depending on thickness, oil composition, and desired moisture content. Inside the fryer, the chips expand slightly and crisp as their internal water content rapidly evaporates. The ridged surface of Ruffles causes the chip to fry unevenly by design, creating micro variations in texture that result in a more substantial bite and greater structural integrity. The ridges also slow oil drainage, allowing a slightly longer dwell time that contributes to the chip's durability and resistance to breakage during dipping. The fryer is equipped with multiple sensors and flow meters that measure oil temperature, turnover rate, chip feed rate, and even in-oil moisture concentration. These data are analyzed in real time by the factory's central control system, allowing operators to make immediate adjustments. In many facilities, The frying process is linked to upstream slicing sensors. For example, if slightly thicker slices are detected coming from the cutter. The fryer conveyor speed is slowed accordingly to ensure proper cook time. As the chips emerge from the fryer, they pass through an oil draining phase. A vibrating conveyor with a perforated surface allows excess oil to drip off. This is immediately followed by an air cooling system that begins to lower the chip's temperature, halting further cooking and locking in texture. Cooling is essential not only for texture stability, but also to prepare the chips for seasoning, which happens shortly after. But before we get to seasoning, there's a critical interlude in the process: moisture analysis and inline quality control. At this stage, a small percentage of chips are diverted through a sampling chute to a nearby test station. Here, technicians use moisture analyzers, color meters, and even acoustic crispness testers to evaluate product characteristics. These tests ensure that the chips meet the factory's targets for final moisture content, color uniformity, and physical integrity. As the freshly fried and cooled Ruffles chips exit the fryer and pass through preliminary quality control, they enter one of the most dynamic and highly controlled stages in the factory: seasoning. This is the phase where the chips receive their final flavor identity, whether it's the original lightly salted variant, sour cream and onion, cheddar and sour cream, jalapeno ranch, or any of the other regional and seasonal flavor options Ruffles is known for. Applying these flavors evenly, consistently, and at high speed while preserving the chip's structural integrity and minimizing waste is a challenge that modern factories solve using specialized equipment and real-time process monitoring. The chips arrive at the seasoning station on a wide, inclined conveyor or vibratory tray that serves two main functions. It spreads the chips out into a single layer to prevent overlap, and it gently agglomerates chips to control their flow into the seasoning drum without damaging them. Due to the ridged shape and the thicker cut of Ruffles compared to standard potato chips, seasoning application must account for deeper surface area and variable orientation. Some chips will face ridge side up, some down, some angled. Seasoning application takes place inside a rotating tumbler drum, also called a flavor drum or seasoning cylinder. This stainless steel drum is set at a slight incline and constantly turns on its horizontal axis, gently lifting and tumbling the chips while they rotate through it. At the entrance to this drum, a continuous metered flow of seasoning powder is dispensed through an auger-based dosing system. The seasoning blend, pre-mixed according to a proprietary formula, includes a combination of salt, natural and artificial flavorings, cheese powders, dehydrated dairy, onion and garlic powders, spices, yeast extract, and anti-caking agents. The dosage rate of the seasoning is tightly controlled via real-time feedback systems. Optical sensors measure the chip volume entering the drum, and the dosing screw adjusts the delivery rate to maintain an ideal flavor to surface area ratio. Too much seasoning leads to clumping, over-salted chips, and waste. Too little results in bland or unevenly flavored chips that fail quality checks. For cheese-based seasonings, which are more moisture sensitive, the flow system may include a nitrogen-purged hopper or desiccant units to prevent clumping in humid environments. Inside the flavor drum, fine misting nozzles also spray a light coating of oil to help the seasoning adhere evenly to the chip surface. This atomized oil does not soak the chips, but rather creates a microfilm that holds the powder in place without compromising crunch. The rate of oil application, angle of spray, and temperature are all adjusted based on the type of seasoning used. For example, heavily coated varieties like cheddar and sour cream require more binder oil and a slightly longer tumbling duration to ensure every chip is fully and evenly coated. Throughout the seasoning process, line operators and quality assurance technicians take random samples every few minutes. These samples are assessed for seasoning coverage, color intensity, and surface powder levels. In more advanced factories, seasoning uniformity is checked with hyperspectral cameras that scan the chips as they exit the drum, detecting variations invisible to the human eye and triggering alerts or auto-calibration if inconsistencies are detected. Once the chips have been properly seasoned, they are transferred to the packaging phase. This is a highly automated and synchronized system that must meet several objectives simultaneously. Protect the chips from breakage, preserve freshness, prevent contamination, provide product information to the consumer, and maintain traceability for safety audits. Packaging begins with product accumulation. Conveyors from multiple seasoning drums may feed into a single accumulation hopper or weigher, depending on line configuration. This hopper temporarily holds chips before they're dispensed into individual bags via a multi-head combination weigher. A multi-head weigher is an advanced piece of equipment with multiple radial feed hoppers arranged in a circular pattern. Each hopper releases a small portion of chips, and a central computer instantly calculates which combination of hoppers adds up closest to the target weight, say 28.3 grams for a single serve bag. This combination is released simultaneously into a timing hopper, which drops the exact weight into a vertical form-fill-seal packaging machine. The VFFS machine forms bags from a continuous roll of printed plastic film, often made from multi-layer laminate materials with barriers against oxygen, light, and moisture. As the chips drop from the weigher into the forming tube, the film is pulled around the tube, sealed lengthwise, and sealed again at the top and bottom with heated jaws, creating a pillow-style bag. Before the top seal is made, a precise dose of nitrogen gas is injected into the bag, a process known as nitrogen flushing. This replaces the oxygen-rich air inside the package to reduce oxidation, extend shelf life, and protect the chips from crushing by slightly inflating the bag. Once sealed, each bag moves through a print station where batch codes, production time, plant ID, and expiration dates are applied using inkjet or thermal printers. Bags then pass through check weighers to confirm accuracy. Any bag outside the designated weight window is automatically rejected and diverted to a rework bin. Metal detectors or X-ray systems scan every bag to ensure no foreign objects have entered the product during processing. This is standard for all snack food production and a critical part of food safety compliance. From there, the sealed and verified bags are grouped into cartons or display trays by robotic case packers. These cartons are sealed with tape or glue and labeled with barcodes and tracking information. Finally, cartons are stacked onto pallets by robotic palletizers, often using suction cup grippers or clamp arms to gently stack without damaging contents. Pallets are wrapped in stretch film and staged in the finished goods warehouse, which is climate controlled to preserve chip texture and flavor. At every point along this packaging line, sensors, programmable logic controllers, and SCADA systems monitor performance metrics, line speed, reject rates, weigher accuracy, sealing temperature, film feed rate, and more. Maintenance logs and process trends are analyzed weekly to identify emerging issues, improve throughput, and reduce product loss. Beyond the physical movement of chips, there are strict sanitation and allergen management systems in place. Since some Ruffles flavors may contain milk, cheese, or other allergens, production lines must be deep cleaned between flavor runs. Clean in place protocols involve dismantling sections of the line using high-pressure washdowns, food-safe detergents, and microbial swab testing. Detailed records of every cleaning cycle are logged and audited regularly. In addition to cleaning, factories must manage cross-contamination risk during flavor changeovers. This includes running purge batches, segregating flavoring agents in separate storage silos, and using dedicated feed lines wherever possible. Every batch of Ruffles is linked back to a full traceability profile, covering raw material lot codes, equipment used, line operator IDs, and environmental conditions during processing. As the freshly packaged Ruffles chips leave the main production floor, the final phase of manufacturing comes into focus. A sophisticated web of logistics, sustainability efforts, continuous process optimization, and digital innovation. While the chips themselves are complete, the factory does not pause. Instead, a parallel system of data analysis, quality assurance, and supply chain orchestration continues operating in the background, ensuring the product not only meets current demand, but evolves to meet future expectations. These behind-the-scenes processes are integral to the long-term efficiency, environmental responsibility, and market success of Ruffles. At the heart of these operations is a factory-wide data infrastructure that tracks every input and output, from raw potatoes to finished pallets. Each batch of Ruffles produced is logged into an integrated manufacturing execution system. This software records the origin of each ingredient, the time and conditions of each processing step, the performance of every machine along the line, and even environmental metrics like room humidity and oil turnover frequency. The MES integrates with enterprise resource planning systems, providing real-time visibility into inventory levels, sales forecasts, and raw material consumption. This data is not merely archived, it's analyzed continuously using advanced analytics platforms and AI-based algorithms. These systems look for patterns in machine downtime, chip reject rates, oil consumption per batch, or seasonal fluctuations in potato solids. If a fryer begins to show a subtle increase in oil absorption, or if seasoning coverage becomes slightly more variable, the system flags it. Maintenance crews and process engineers receive alerts and can intervene before the issue affects product quality or efficiency. Predictive maintenance models also help avoid equipment failure by identifying when motors, pumps, or slicers are approaching wear thresholds. One of the key areas of focus in modern Ruffles factories is oil management. Frying oil is both a major cost and a major variable in product consistency and sustainability. The oil in the continuous fryer is constantly recirculated through filtration units that remove chip fines and particulates. Inline sensors monitor the free fatty acid content, color, and total polar materials in the oil, 3 indicators of oil degradation. When these metrics exceed defined limits, the system initiates partial or full oil replacement protocols. Some facilities have implemented smart fryer systems that dynamically adjust oil flow and heat profiles based on chip load and moisture level, significantly reducing oil turnover without compromising flavor or texture. Environmental sustainability is another priority embedded into Ruffles manufacturing. Frito-Lay, the parent brand, has committed to reducing water, energy, and greenhouse gas emissions across its snack food plants. One way this is achieved is through water reclamation. The flume water used to transport, wash, and rinse potatoes is filtered, UV treated, and reused multiple times before final disposal. Similarly, the steam peelers are equipped with condensate recovery systems that recycle steam condensate back into the boiler system, conserving energy and reducing water use. Electricity usage is optimized through variable frequency drives on conveyors and pumps, while LED lighting, motion sensors, and insulated cooling tunnels help minimize unnecessary energy waste. Some Ruffles production plants are now partially powered by renewable sources, including solar panels and biogas captured from on-site food waste digesters. Waste heat from fryers is recovered using heat exchangers and used to preheat incoming wash water, further boosting energy efficiency. Waste management is another crucial part of the factory's operations. Trimmings from biscuit cuts, chips rejected for size or overcooking, and seasoning overage are all collected, logged, and sent to animal feed processors or converted into biofuel when food safety protocols allow. Even the excess oil removed during de-oiling phases is collected, filtered, and sold to biodiesel manufacturers. Packaging materials are optimized for minimal plastic use, and packaging engineers continuously evaluate new laminates that offer better barrier performance with reduced environmental impact. The production of Cheetos begins not with cheese or seasoning, but with one humble ingredient: corn. In fact, the specific type of corn used in Cheetos manufacturing is carefully selected and processed to meet exacting technical standards before it even enters the plant. The base product of every Cheeto is degermed cornmeal, derived from a variety of field corn that is specially cultivated for its high starch content and low fat levels. This corn must produce a uniform, predictable puff when subjected to extreme heat and pressure, so its density, moisture content, and kernel hardness are closely monitored even at the agricultural stage. Farmers contracted by the manufacturer are required to meet tight tolerances in grain quality, harvesting methods, and post-harvest drying to ensure the raw corn will meet the standards for industrial puffed snack production. Once harvested and transported to the ingredient supplier, the corn undergoes an initial cleaning to remove plant debris, soil, and foreign materials. It is then taken through a degermination process, in which the outer bran layer and the germ, the oil-rich, nutrient-dense part of the corn kernel, are removed. This step is essential. While germ and bran contain healthy fats and proteins, their presence can negatively impact the expansion properties and shelf life of the final product. Germ oil can go rancid over time and interfere with the consistent puff structure that defines a Cheeto. What remains after degermination is the starchy endosperm, milled down into a fine cornmeal that becomes the building block of every puff. This cornmeal is then enriched with a blend of vitamins and minerals, including riboflavin, niacin, iron, and folic acid. The enrichment not only helps meet nutritional labeling requirements, but also contributes to uniformity in the extrusion process, as these additives influence how the mixture reacts under heat and pressure. The resulting product is a dry, golden yellow flour with a specific granulation profile tailored to the plant's extrusion parameters. Before it is used on the production line, the cornmeal is stored in temperature and humidity-controlled silos directly connected to the processing plant. These silos often hold hundreds of metric tons of product and are designed to keep the cornmeal in a stable state for extended periods. Pneumatic systems transfer the cornmeal through stainless steel pipelines to weigh hoppers on the factory floor, where batch sizes are precisely measured. Real-time inventory sensors track the flow of material and communicate with the factory's central control system to automatically replenish supply lines as needed, ensuring uninterrupted production. Now it's time for the first transformation phase: hydration and preconditioning. The cornmeal is metered into a continuous mixing system where it is blended with water or steam to raise its moisture content to a narrowly specified range, usually between 15% and 20%. This step is essential to prepare the starch molecules for gelatinization. The equipment used here is not unlike a ribbon blender or paddle mixer, which agitates the mixture thoroughly to ensure every granule of cornmeal is evenly hydrated. Water is introduced through atomizing nozzles positioned at calculated intervals along the mixer's length, and multiple moisture sensors along the pathway feed back to the PLC system to adjust water input in real time. This moist mixture, often referred to as dough, despite its loose, crumbly texture, is held briefly in a conditioning tank to allow for even moisture distribution. The temperature and residence time are carefully controlled. If the mix is too hot or too wet, it may pre-gelatinize and clog the extruder. Too dry, and it won't expand properly. During this stage, the product is slowly moved along a jacketed screw conveyor that maintains a consistent temperature and prevents clumping. Now we arrive at the heart of the production line, the extruder. Industrial Cheetos are made using a twin screw extruder, one of the most sophisticated and critical machines in the plant. The twin screw configuration allows for highly controlled processing of the corn mixture, providing better mixing, higher shear, and superior control over temperature and pressure compared to single screw models. The hydrated cornmeal is fed into the extruder barrel, where it encounters two rotating screws that convey the material forward under intense mechanical pressure. External heaters line the barrel and raise the temperature incrementally as the product moves through each zone. Inside, shear forces generated by the screws convert some of this mechanical energy into heat, further increasing the temperature of the dough. The intense conditions inside the extruder, pressure in the range of 200 to 500 psi, and temperatures from 130 degrees Celsius to 180 degrees Celsius, cause the starches in the cornmeal to gelatinize and the water to superheat. The dough undergoes plasticization, becoming a molten mass under pressure. As this molten dough reaches the end of the barrel, it is forced through a die, the precision-crafted metal plate that defines the shape of the puff. The die hole is round and small, but as the dough exits into atmospheric pressure, the superheated water in the mixture flashes into steam, causing the structure to puff and expand dramatically in a fraction of a second. This rapid expansion is responsible for the iconic airy texture of a Cheeto. Just outside the die, rotating knives spin at high speed, slicing the continuous stream of puff into uniformly sized segments. The speed of the knives determines the length of the puff, while the pressure and temperature within the extruder affect its diameter and density. But even after this high-tech transformation, the newly extruded Cheetos are far from finished. They are still pale, moist, and bland, essentially unseasoned corn puffs. The next stage is all about turning them into the crunchy, craveable snack that consumers instantly recognize. First, the extruded pieces are conveyed via vibrating trays to a frying system. Here, they're submerged in hot oil, typically corn or canola oil, at carefully controlled temperatures ranging between 160 degrees Celsius and 180 degrees Celsius. The residence time in the fryer is only about 20 to 40 seconds, but in that time, the moisture content is reduced dramatically from around 15% to under 2%. This not only creates the final crispy texture, but also deepens the color slightly, giving the snack its characteristic golden hue. The fryer itself is a marvel of engineering, equipped with multiple sensors and filtration systems. Oil turnover rates are high, meaning that fresh oil is constantly added, while spent oil is removed and filtered to maintain quality. Skimmers remove any floating particles, and oil chemistry is monitored for signs of oxidation, free fatty acid levels, and polymerization. If any readings fall outside of the strict parameters, the fryer automatically triggers corrective actions, dosing with fresh oil, increasing filtration, or even pausing the line to prevent compromised batches from continuing downstream. After exiting the fryer, the Cheetos are carried on mesh conveyors through an air cooling tunnel. High-powered fans blow ambient or conditioned air over the freshly fried snacks, bringing them to a safe handling temperature and ensuring any surface oil solidifies just slightly to help the seasoning adhere. These cooling conveyors are extended and designed with soft vibratory motion to prevent breakage, ensuring that the delicate puffs remain intact before entering the seasoning phase. Next, the Cheetos are transferred into a massive rotating flavor drum, where their bland exterior is transformed by a shower of powdered cheese blend. But before we dive into the complexities of seasoning, we'll need to explore how oil coating is applied for adhesion and how powder distribution systems are calibrated to ensure every single puff gets the perfect amount of flavoring. This next part of the production process is where precision meets sensory science, and the result is the addictively cheesy snack that has become a global favorite. Now it's time to dive into one of the most iconic and intricate stages in Cheetos manufacturing, the flavoring phase. This is where the bland, puffed, and fried corn kernels are transformed into the intensely savory, cheese-coated snacks recognized all over the world. The process of seasoning Cheetos is not merely about tossing on a bit of cheese powder. It is an engineered, tightly controlled operation that determines product consistency, taste balance, visual appeal, and even mouthfeel. Everything from the size and porosity of the puff to the electrostatic charge of the powder particles is taken into account in this phase. After exiting the cooling conveyor from the fryer, the puffs are transferred into large rotating cylindrical drums called flavor tumblers. These drums are typically positioned on a gentle incline and rotate slowly, creating a continuous cascade of puffs inside the drum that exposes every surface area of each piece as they tumble forward. This mechanical tumbling is crucial. It ensures an even coating without crushing the fragile, aerated product. Inside the drum, two key applications occur almost simultaneously. First, a fine mist of oil is sprayed onto the hot puffs. Then, a controlled stream of seasoning powder is dispensed over the tumbling mass. The oil, which is typically a neutral vegetable oil like corn or canola, plays several roles in this step. Primarily, it acts as an adhesive layer that allows the seasoning powder to stick effectively to the puff's surface. Additionally, it helps activate the flavor compounds in the powder blend, carrying volatile aroma molecules and enhancing taste perception. The oil spray system uses ultra-fine atomizing nozzles that are precisely calibrated to deliver a uniform coat without oversaturation. Too much oil, and the puffs become greasy and soggy. Too little, and the powder won't adhere properly, leading to uneven seasoning distribution and flavorless bites. The timing, angle, and rate of oil application are closely monitored and adjusted by sensors and programmable logic controllers. Real-time feedback systems measure oil usage, droplet size, and the thermal signature of the puffs to ensure that coating is optimal under varying production speeds or ambient conditions. This level of automation ensures consistency across thousands of pounds of product produced per hour. As the puffs are coated in oil, the seasoning powder is introduced using a vibratory feeder or screw conveyor system. The powder is held in a hopper mounted above the flavor drum and is dispensed through controlled openings at a fixed rate, matched to the flow of puffs. The exact dosing rate depends on the type of Cheetos being produced. Flamin' Hot varieties require slightly more powder per unit than the traditional cheese puffs due to differences in density, powder, granularity, and flavor intensity. The seasoning blend itself is a complex formulation engineered not only for taste, but also for flow characteristics, adhesion, and shelf stability. The base of the powder is often dehydrated cheddar cheese, spray-dried into a fine particle form. This is combined with whey or whey protein concentrate, maltodextrin, salt, monosodium glutamate, MSG, disodium phosphate, citric acid, and natural or artificial flavors. Each of these ingredients plays a very specific role. Maltodextrin, for example, acts as a carrier and anti-caking agent that helps the powder distribute evenly and resist clumping. Citric acid provides a tangy bite that enhances cheese flavor. MSG boosts umami and deepens savory perception. Color additives like annatto or oleoresin paprika for classic cheese and red 40 or yellow 6 for Flamin' Hot are oil dispersible pigments that give the snack its vivid appearance without creating spotting or streaks. The particle size distribution of the powder is engineered to align with the surface texture of the puffed snack. Powder that's too coarse will fall off, and powder that's too fine will clump or create an overly dusty texture. To prevent powder fallout, electrostatic systems are sometimes used in high-speed lines. In these cases, the powder is given a minor static charge to improve its affinity for the puff surface, minimizing waste and improving adhesion. Inside the flavor tumbler, the balance of oil spray and powder distribution creates a beautiful, uniform layer of seasoning that fully coats each puff without pooling at the bottom of the drum or leaving bald spots on the product. The drum's internal design is key. Angled baffles gently lift and drop the puffs to keep them moving without subjecting them to mechanical stress. As the snacks make their way to the end of the drum, they are now visually and sensorially transformed. Bright orange, evenly coated, and bursting with aroma. Once the seasoning phase is complete, the fully flavored Cheetos are gently transitioned to the final conveyor belt systems that lead to the packaging area. Here, another series of quality control measures come into play. Inline camera systems inspect color uniformity and powder coverage using advanced image recognition algorithms. If a section of the product stream is detected to have an irregular appearance, whether due to light seasoning, overcoating, or discoloration, it is flagged and diverted from the main line for manual inspection or disposal. At this point, the Cheetos are still vulnerable to moisture pickup, oxidation, and mechanical damage, so the packaging process must move swiftly and with precision. The conveyor system delivers the finished puffs to a multi-head weigher mounted above the bagging machines. This machine uses multiple weigh hoppers to rapidly measure exact product portions, typically in the range of 28 g to 250 g per serving, depending on the bag size. These weighers use real-time load cell feedback to select the optimal combination of buckets to match the target weight, within a tolerance as tight as +no. 2G. Each pre-measured portion is released down a chute into a vertical form-fill seal (VFFS) machine. These machines work by pulling a flat roll of pre-printed film through a collar that forms it into a tube. The bottom of the tube is heat sealed to create the first seam, the Cheetos are dropped in, and then the top is sealed and cut, simultaneously forming the bottom seal of the next bag in line. These machines can fill and seal over 100 bags per minute per lane, and multiple lanes often run in parallel for large-scale production. The film used for the packaging is multi-layered and engineered to provide barrier protection against light, oxygen, and moisture. It typically includes an outer polyester film for print quality and visual appeal, a middle layer of aluminum or metallized polypropylene for oxygen and light resistance, and an inner polyethylene layer for heat sealing and moisture resistance. As each bag is sealed, a date code, batch number, and factory identifier are printed using high-speed inkjet printers for traceability. Just after sealing, every bag passes through a series of checkpoints. Metal detectors scan for any foreign objects, vision systems verify print alignment and code readability, and weight checkers ensure compliance with regulatory standards. Non-conforming bags are automatically ejected onto a rejection conveyor, where they are set aside for manual inspection. Approved bags are then grouped and packed into cardboard shipping cartons by robotic pick-and-place systems or automated drop packers. These cartons are sealed, barcoded, and routed to the palletizing station. Here, industrial robotic arms stack the cartons onto wooden or plastic pallets using optimized patterns for stability and load balance. As each pallet is completed, it is wrapped in stretch film to secure the load and protect it from dust and humidity during storage and transportation. The palletized loads are then scanned into the plant's warehouse management system, which tracks location, batch status, and distribution destination. Some pallets are moved to ambient storage if they are designated for short-haul routes, while others are transported to climate-controlled storage areas that maintain low humidity and consistent temperatures, ensuring that the product maintains its texture and flavor until it reaches its final destination. What follows is the outbound logistics phase, where the pallets are loaded onto trucks, routed to distribution centers, and delivered to retailers. But for now, every step inside the production facility, from the moment the cornmeal is hydrated to the final bag, passing the last inspection point, has been a meticulously engineered series of chemical, mechanical, and sensory transformations. Every component of the Cheetos production line is designed not just for efficiency and speed, but to deliver a reliably indulgent experience in every bag. And it all happens in a continuous, automated, high-output environment that must maintain exacting standards of quality, cleanliness, and consistency hour after hour, shift after shift. One of the key operational pillars at this stage is environmental control. Temperature, humidity, and airflow within the production zones are tightly monitored and controlled around the clock. Cheetos, especially after frying and seasoning, are highly sensitive to ambient conditions. If the air in the seasoning or packaging area carries too much humidity, for instance, the cheese powder may begin to clump, reducing its dispersibility and leading to uneven coating. Worse still, excess moisture can cause the puffs to begin absorbing water from the air, softening the texture and compromising the crisp, dry bite expected by consumers. To prevent these issues, HVAC systems specifically engineered for food processing environments are deployed throughout the Cheetos plant. These systems do more than just heat or cool. They dehumidify, filter, and exchange the air in sensitive zones at rapid intervals, ensuring a constant flow of purified, dry, temperature-stabilized air. Some areas, such as the seasoning tumblers or the vertical form-fill seal zone, may be isolated with positive air pressure to ensure that external air, dust, and contaminants do not seep into these critical zones. These environmental systems are integrated with digital controls that feed data into the facility's central monitoring hub. Temperature and humidity data are tracked every few seconds, and if any reading moves outside of pre-programmed tolerances, automatic alarms notify technicians to investigate immediately. In some cases, the system will even halt upstream processes automatically to prevent production under unsuitable conditions, protecting product quality. While environmental controls maintain external conditions, another system ensures the quality of what's happening on the line, inline quality assurance, and real-time analytics. Throughout the Cheetos line, from extrusion to bagging, dozens of sensors, scanners, and cameras work in unison to gather data on key quality metrics. These include moisture content, oil absorption rate, puff size, color uniformity, seasoning coverage, and weight per unit. Each of these factors contributes not only to taste and mouthfeel, but to customer satisfaction and regulatory compliance. Advanced laser micrometers and stereo imaging cameras measure the dimensions of each puff as it moves across the line at high speed. If puffs fall outside the programmed size range, either due to inconsistent extrusion pressure, die blockage, or improper cutting, those units are flagged and rejected automatically using pneumatic diverting arms. Simultaneously, optical sensors inspect the color of the fried puff to confirm it matches brand-specific targets. Color variation could indicate improper frying time, fluctuating oil temperature, or oil degradation. The system will trigger alerts or shut down sections of the line if it detects drift from acceptable limits. Another important part of inline quality is the metal detection system. Every snack must pass through high-sensitivity metal detectors or, in some cases, X-ray systems just before packaging. These devices scan for trace amounts of ferrous, non-ferrous, and stainless steel contaminants which could originate from worn machinery parts, upstream, or during maintenance. The sensitivity of these machines is such that they can detect metallic particles smaller than a millimeter in diameter. If a contaminated bag is identified, it is automatically ejected from the line, recorded in a digital log, and sent for root cause analysis. In high-output snack manufacturing, product changeovers are another critical concern. A single plant might produce multiple Cheetos variants: classic cheese, flamin' hot, jalapeno cheddar, and limited editions on the same line, sometimes switching several times per day. To avoid cross-contamination of flavor profiles and allergens, the factory must execute a full product changeover, which includes both physical and procedural steps. The final bags of one variant are run through the line until the seasoning and product types are completely cleared. Following that, dry cleaning and wipe down protocols are enacted on exposed surfaces. In flavor tumbler zones and powder feeding systems, residue removal is handled by a combination of mechanical vacuums, compressed air nozzles, and in some cases, wet cleaning cycles. Pipes carrying seasoning powder are often disassembled and cleaned manually or flushed with air-driven pigs, foam or rubber projectiles that scrape the interior of the tube clean as they are propelled by compressed air. All cleaning steps are verified through ATP, adenosine triphosphate, swab tests or allergen-specific strip tests to confirm the line is ready for the next product. Equipment cleaning and sanitization extend far beyond changeovers. Each section of the production line is scheduled for deep cleaning on a regular basis, with some components cleaned daily, others weekly, and critical systems like oil fryers undergoing monthly shutdowns for intensive maintenance. Every cleaning task is documented in a digital sanitation log that includes time-stamped photos, chemical usage records, technician ID, and verification by a supervisor. This log ensures compliance with food safety regulations and internal auditing systems. Speaking of oil fryers, one of the more maintenance-intensive systems in the Cheetos plant is the oil management setup. Used frying oil is constantly cycled through multi-stage filtration systems that remove fine particulates and oxidized residues. Inline sensors monitor oil color, free fatty acid content, and total polar compounds, all indicators of oil degradation. When thresholds are approached, fresh oil is introduced, and a portion of the old oil is purged to waste recovery tanks. This spent oil is not discarded haphazardly. Instead, it is captured and sent to third-party processors who refine it for use in biodiesel production or industrial lubricants, creating a closed-loop waste management process that supports sustainability goals. Seasoning systems have their own challenges in terms of dust and waste control. Cheese powder and spice blends are notoriously airborne, so extraction hoods fitted with HEPA filters are positioned above tumblers and conveyors to capture stray particles. These systems not only keep the air clean for workers, but also prevent buildup on surfaces and reduce cross-contamination risk. Powder recovered in this way is not reused in production, but is collected and weighed for waste tracking. Many factories monitor seasoning powder yield versus usage to optimize application and reduce excess without compromising flavor intensity. Additionally, factories employ floor-level waste segregation systems, where organic waste, such as broken puffs or overcooked batches, is separated from packaging materials and cleaning byproducts. Organic snack waste is often sent to animal feed processing plants or used in anaerobic digesters to generate energy, while plastics are compacted and shipped to recycling partners. These systems not only reduce landfill usage, but also lower the facility's total environmental impact per unit of product. Every phase of the factory's operation is governed by a robust system of documentation and auditing. Real-time production data is logged into the Manufacturing Execution System, MES, which connects to the plant's Enterprise Resource Planning, ERP, platform. This system allows plant managers to track every batch of Cheetos from cornmeal input to palletized output. If a quality issue is flagged post-distribution, every input, cornmeal batch, oil lot, seasoning blend, even the operator ID can be traced within seconds. This level of transparency is essential for large brands that operate under continuous scrutiny from regulators, retailers, and consumers alike. All these systems, from the air handlers and fryers to the conveyors and flavor blenders, are monitored by a central control room staffed by trained process engineers and operators. The control room acts as the nerve center of the factory, Touchscreen interfaces display real-time data on line performance, yield percentages, waste figures, and energy usage. Alarms and alerts notify the team of any deviation in pressure, temperature, fill levels, or machine health. The staff can make remote adjustments, schedule maintenance tasks, and even initiate partial or full shutdowns directly from their stations. In many facilities, predictive analytics platforms are integrated into these systems. Using machine learning algorithms, these platforms analyze historical and current data to forecast when a component might fail, how yield might shift under ambient changes, or what impact a change in oil temperature might have on puff expansion. This allows for proactive decision-making, reducing downtime and maximizing efficiency. The manufacturing of Pringles is an intricate process that combines food science, precise engineering, and large-scale automation to produce the uniform, crisp, and stackable potato chips recognized worldwide. Unlike traditional potato chips, which are sliced from whole potatoes and fried, Pringles are created from a specially formulated dough made primarily of dehydrated potato flakes, starches, and seasonings. The process of making Pringles in a factory involves several key stages, each meticulously designed to ensure the final product meets strict quality standards. It all begins with selecting the right raw ingredients, primarily potatoes, which serve as the foundation of the chips. However, not just any potatoes will do. Pringles require specific varieties with the right starch content to achieve the desired texture. High starch potatoes are preferred because they contribute to the crispness of the final chip and help bind the dough together during production. Once the right potatoes are sourced, they are transported in bulk to the factory, where they undergo an initial round of inspection. Before entering the processing phase, the potatoes are stored in climate-controlled environments to maintain their quality. Even small variations in temperature and humidity can affect their starch content, which in turn impacts the final texture of the chip. Workers constantly monitor these storage conditions to ensure that the potatoes remain in an optimal state before processing. When ready for use, the potatoes are moved to the preparation area, where they go through a rigorous washing process. Large industrial washers, equipped with rotating brushes and high-pressure water jets, remove dirt, debris, and any residual pesticides from the potato skins. This step is crucial, as any impurities at this stage could compromise the quality of the final product. The washing process is thorough, ensuring that only the cleanest potatoes make it to the next stage. Once cleaned, the potatoes are sent through a peeling machine, which uses either steam or mechanical abrasion to remove the skins efficiently. Steam peeling is a common method in large-scale food production, as it allows for quick and uniform removal of the skin with minimal waste. The peeled potatoes are then conveyed to slicing machines, but unlike conventional potato chips, where these slices would be fried, the goal here is to break them down into a form that can be processed into a dough. To achieve this, the sliced potatoes are sent through a pre-cooking stage, where they are partially heated to help break down their cellular structure. This step makes it easier to remove moisture later in the process. The pre-cooked potato slices are then transferred to large industrial dryers, where hot air circulates around them, slowly extracting moisture until they are fully dehydrated. What remains after this process is not whole potato slices, but thin, brittle flakes of potato. These dehydrated potato flakes serve as the primary base for Pringles and are stored in large silos within the factory. However, potato flakes alone are not enough to form the distinctive shape and texture of Pringles. Additional ingredients must be added to create the dough that will eventually be shaped into chips. When it is time to begin the production of a batch, the potato flakes are carefully measured and transferred to industrial mixing machines. Inside these massive mixers, the flakes are combined with other ingredients such as cornstarch, wheat starch, emulsifiers, and small amounts of salt and sugar. These additional ingredients help give Pringles their characteristic crunch and structure while also ensuring that the dough is flexible enough to be shaped without crumbling. Water is then gradually added to the dry mixture, and the entire batch is kneaded until it forms a smooth, pliable dough. This step is one of the most crucial in the entire process, as the consistency of the dough determines how well the chips will hold their shape and how they will fry later in the process. Too much water and the dough will be too soft, making it difficult to handle. Too little and it will become too dry, leading to chips that may crack or break during production. The mixing process is highly automated, with computer-controlled machines ensuring that every batch has the same precise ratio of ingredients. Factories use real-time monitoring systems to adjust the moisture content and consistency of the dough as needed, ensuring uniformity across millions of chips. Any slight variation in dough quality could lead to a final product that does not meet the brand's strict standards, so maintaining precise control over this step is critical. Once the dough reaches the perfect consistency, it is ready to be shaped. However, before this can happen, the dough must be processed into thin sheets. This is accomplished using large industrial rollers, which gradually flatten the dough to an exact thickness. The thickness of the dough sheet is critical, as it determines the final texture and crunch of the Pringles. If the dough is too thick, the chips will be too hard. If it is too thin, they may become fragile and brittle. The flattened dough sheet is then conveyed to a cutting station, where specially designed rotary cutters stamp out individual chip shapes. Unlike traditional potato chips, which take on random forms based on how they are sliced, Pringles are designed to be identical in size and shape. Each cutter is engineered to create the precise oval form that allows the chips to stack perfectly inside their cans. During this process, any excess dough that remains after the chips are stamped out is collected and fed back into the mixing stage. This recycling process minimizes waste and ensures that as much of the raw material as possible is used efficiently. The ability to reuse excess dough is one of the advantages of making Pringles from a formulated dough rather than whole potato slices. At this point, the chips are still in their raw, unbaked form. They have been cut into shape, but they are not yet crispy. To achieve their signature texture, they must go through the next phase of the manufacturing process, where they will be carefully molded and cooked. This is where Pringles truly begin to take on their distinctive identity. Before they can be cooked, the raw chips must be shaped into their famous curved form. This is done using a specialized conveyor system that gently places each chip into a custom mold. These molds are designed to hold the chips in a precise curve, known as a hyperbolic paraboloid, which is what gives Pringles their unique stacking ability. The shape is not just for aesthetics. It also helps distribute weight evenly when the chips are stacked in their can, preventing them from breaking easily. Once placed in the molds, the chips are conveyed toward the cooking stage, where they will be exposed to controlled heat and oil. This step is critical in achieving the crispy, golden brown texture that Pringles are known for. However, unlike traditional potato chips, which are deep fried in vats of hot oil, Pringles are cooked in a specialized method that ensures even frying while maintaining their precise shape. At this point, the chips are not yet fully cooked, nor have they been seasoned. The next phase will involve exposing them to heat and oil, followed by a careful seasoning process that gives each chip its final flavor. But before that happens, factory workers and automated quality control systems continuously monitor the process to ensure that each chip is perfectly shaped and free of defects. With the raw dough pieces now cut into their precise, uniform shapes and carefully placed into their curved molds, they are ready to undergo the critical cooking process. This step is what transforms the soft, pliable dough into the crisp, golden brown chips that Pringles are known for. Unlike traditional potato chips that are submerged in deep vats of hot oil and fried freely, Pringles undergo a much more controlled cooking method to maintain their exact shape and texture. The chips, still nestled in their curved molds, travel along a continuous conveyor belt into an industrial fryer. This fryer is designed to ensure that each chip is cooked at an exact temperature for a precise amount of time. The temperature inside the fryer is meticulously controlled, typically ranging between 300 degrees Fahrenheit and 375 degrees Fahrenheit, depending on the specific requirements of the batch being produced. The goal is to remove moisture from the chips without overcooking them, achieving the perfect crunch while preserving the uniform shape. The frying process takes only a matter of seconds, but within that short time, several crucial chemical reactions occur. The high heat causes the remaining water content inside the dough to rapidly evaporate, creating tiny air pockets that give Pringles their distinctive lightness. At the same time, the starches and sugars in the dough undergo the Maillard reaction, a chemical process that causes browning and enhances the chip's flavor by developing rich, slightly nutty, and toasted notes. Because the chips are fried in a controlled environment while sitting inside their molds, they do not curl or warp the way traditional potato chips do. Instead, they maintain their signature hyperbolic paraboloid shape, which is key to their ability to be stacked efficiently without breaking. To ensure even cooking, the oil circulates through the fryer using a sophisticated system that maintains uniform heat distribution, preventing any chip from becoming overcooked or undercooked. Once the chips have been fried to perfection, they must be quickly removed from the hot oil to prevent excessive absorption of fat, which could compromise their texture and make them overly greasy. The chips exit the fryer onto a draining conveyor, where excess oil is gently shaken off. A series of air jets then blow away any remaining oil droplets, ensuring that each chip has the right balance of crispness without being overly oily. The amount of oil that remains in the final product is carefully monitored, as even a small deviation in fat content could alter the texture and mouthfeel of the chips. After the excess oil is removed, the chips continue along the conveyor system into a specialized drying chamber. This drying stage serves a dual purpose. It helps eliminate any remaining moisture to extend the shelf life of the chips and ensures that they retain their crisp texture. If any residual moisture remains, it could lead to sogginess or even microbial growth, which would compromise the quality of the product. The drying chamber operates using a controlled flow of warm air, which gently removes any lingering humidity without exposing the chips to excessive heat. This is a crucial step because overdrying could make the chips too brittle, leading to breakage before they even reach the packaging stage. The process must strike a balance between removing moisture while preserving the ideal crunch. Now that the chips have been properly fried and dried, they still lack one essential component: flavor. While the dough contains some base seasonings, such as salt, the majority of Pringles' signature flavors are added after cooking. At this point, the chips are still relatively plain, resembling lightly salted potato crisps. To give them their final taste, they must go through the seasoning process. The chips enter a large rotating drum, which is a key part of the flavoring system. This drum functions much like a giant tumbler, gently tossing the chips to ensure that each one is evenly coated with seasoning. However, before the seasoning can be applied, the chips must be lightly misted with a fine spray of oil. This thin coating of oil acts as an adhesive, allowing the seasoning to stick uniformly to each chip without clumping. Once the oil mist has been applied, the chips move further into the drum, where a precise amount of seasoning powder is dispensed. This powder is a proprietary blend of dehydrated spices, artificial and natural flavors, and other ingredients that create the distinct taste of each Pringles variety. Whether it's the classic original, sour cream and onion, barbecue, or any of the many other flavors available around the world, each seasoning mix is carefully crafted to deliver a consistent and recognizable taste. The rotation of the drum ensures that the seasoning is distributed evenly across all chips, preventing any one chip from receiving too much or too little flavor. This is crucial because even slight inconsistencies in seasoning distribution can affect the overall eating experience. Too much seasoning on one chip could make it overpowering, while too little could make it bland. The factory's precision-engineered system ensures that every chip in a can has the same delicious taste. To confirm that the seasoning has been applied correctly, automated sensors monitor the amount of seasoning powder dispensed and the overall coating level. These sensors use advanced optical and weight measurement technologies to detect any irregularities in the seasoning process. If an issue is detected, such as an uneven application or a deviation from the standard amount of seasoning, the system can automatically adjust to correct the problem in real time. Now fully seasoned, the chips continue their journey toward the final stages of production. At this point, they must be carefully handled to prevent breakage before they are packaged. Despite their sturdy design, Pringles are still delicate enough to crack if handled too roughly, so the conveyor system is designed to gently transport them through the factory. Before reaching the packaging area, the chips pass through another quality control checkpoint. High-speed cameras and sensors inspect each chip to ensure that they meet the brand's strict standards. Any chips that are overly browned, misshapen, or broken are automatically removed from the line. These rejected chips do not go to waste. They are often ground down and repurposed as part of the raw ingredient mixture for new batches, minimizing food waste in the production process. Now, with their perfect shape, crisp texture, and flavorful coating, the chips are ready for packaging. However, the packaging process itself is an essential part of what makes Pringles so unique. Unlike traditional potato chips, which are packed into bags that allow for some degree of breakage, Pringles are carefully stacked inside rigid cylindrical cans. This design ensures that they remain intact from the moment they leave the factory to the time they are opened by consumers. As the chips approach the packaging area, specialized machines align them into precise stacks. These machines use gentle vibrations and suction mechanisms to ensure that each stack is perfectly arranged before being inserted into the canisters. The stacking process is incredibly precise. Any misalignment could cause the chips to break during transportation. At this point, the Pringles are nearly ready to be sealed and sent out for distribution, but there are still a few final steps left to complete before they can reach store shelves. The packaging must ensure freshness, provide product protection, and meet branding and labeling requirements. In the next stage, the stacked chips will be inserted into cans, sealed for freshness, and prepared for shipment. With the freshly seasoned chips perfectly stacked and aligned, the Pringles are now ready for the crucial packaging stage. This process is just as important as the manufacturing and cooking steps, as it ensures that the chips remain intact and fresh until they reach consumers. Unlike traditional potato chips, which are packed loosely in bags that allow for some level of breakage, Pringles are carefully placed into rigid cylindrical cans, a signature feature that sets them apart from other snack foods. The packaging process begins with the automatic loading of the Pringles stacks into their respective canisters. These canisters, made from a combination of cardboard and aluminum lining, are designed to provide structural support, protecting the delicate chips from breaking during transport. The cans arrive at the packaging station in a flattened state and are quickly formed into their cylindrical shape by specialized machinery. The inner lining of the cans is coated with a food-safe aluminum layer, which helps to preserve freshness by preventing exposure to moisture and air. Once the cans are fully formed, they are transported to the filling station, where the Pringles stacks are precisely inserted into them. This process requires extreme precision, as any misalignment could cause the chips to shift or break. A combination of gentle vibrations and suction mechanisms ensures that the stacks remain stable as they are guided into the canisters. If even a single chip in the stack is out of place, the entire batch may be rejected to maintain quality standards. As the filled cans move along the conveyor, they reach the sealing station, where a thin foil seal is applied to the top of each canister. This foil seal serves multiple purposes. It locks in freshness, prevents air from entering, and ensures that the chips remain crisp for an extended period. The application of the seal is a highly controlled process that uses a combination of heat and pressure to create an airtight bond between the foil and the can's rim. Automated sensors continuously monitor the sealing process, detecting any imperfections or leaks. If a faulty seal is identified, the can is removed from the production line and either reprocessed or discarded. After the foil seal is in place, a plastic lid is applied to the top of the can. This lid serves as a secondary protective barrier and allows consumers to reseal the container after opening. The lids are typically made from lightweight but durable plastic that ensures a secure fit while remaining easy to remove. Before being placed onto the cans, the lids are inspected for defects, such as warping or cracks, which could compromise the product's freshness. With the Pringles cans now fully assembled and sealed, they move toward the labeling and branding station. Here, pre-printed labels featuring the Pringles logo, flavor designation, and nutritional information are carefully wrapped around each canister. These labels are made from high-quality materials that are resistant to moisture and tearing, ensuring that they remain intact throughout the product's journey from the factory to store shelves. A combination of heat and adhesive is used to secure the labels in place, ensuring a smooth, wrinkle-free application. Once labeled, the finished cans undergo another round of quality control checks. Automated cameras and sensors scan each can to verify that the labels are correctly applied and free of defects. Any cans with misaligned or damaged labels are removed from the line and either relabeled or discarded. Additionally, random samples from each batch are taken for more detailed inspections, where factory workers check for overall product integrity, including stack alignment, sealing effectiveness, and crispness. After passing the final quality control checks, the Pringles cans are grouped together for bulk packaging. This step involves placing multiple cans into larger cardboard cartons or shrink-wrapped bundles, which make transportation and stocking more efficient. The bulk packaging process is automated, with robotic arms carefully arranging the cans into pre-formed boxes or wrapping them in durable plastic film. The goal is to maximize space efficiency while ensuring that the cans are securely held in place to prevent movement during shipping. Once the bulk packaging is complete, the cartons are sealed and labeled with batch numbers, expiration dates, and tracking information. These labels allow for easy inventory management and ensure that products can be traced back to their specific production batch if necessary. The cartons are then stacked onto pallets, which are loaded onto trucks for distribution to retailers, supermarkets, and convenience stores around the world. Before being shipped out, the finished products undergo a final inspection to verify that the correct quantities and flavors have been packed for each order. Logistics teams coordinate with distribution centers to determine the most efficient shipping routes, ensuring that Pringles reach their destinations as quickly and cost-effectively as possible. Since Pringles are a globally recognized brand, this distribution network spans multiple countries, requiring careful coordination between factories, warehouses, and retailers. Throughout this entire process, Pringles manufacturers adhere to strict hygiene and safety regulations to ensure product quality and consumer safety. Factory workers follow rigorous sanitation protocols, wearing protective gear such as gloves, hairnets, and face masks to prevent contamination. The The production facilities are regularly inspected by quality assurance teams and food safety organizations to ensure compliance with industry standards. In addition to maintaining high production standards, Pringles manufacturers are constantly exploring ways to improve sustainability and reduce waste. The company has implemented initiatives to minimize environmental impact, such as optimizing energy usage in production plants, recycling excess packaging materials, and reducing food waste by repurposing rejected chips and excess dough. In some regions, Pringles packaging has been redesigned to use more eco-friendly materials, with ongoing efforts to further enhance the sustainability of the product. While the cans of Pringles are now ready to be shipped to stores, the journey does not end there. Once they arrive at retail locations, they must be carefully stocked to ensure they remain in pristine condition for customers. Store employees follow specific stocking guidelines to prevent the cans from being crushed or stacked improperly. The cylindrical shape of the canisters allows them to be displayed neatly on shelves, creating an organized and visually appealing presentation. For consumers, the convenience of Pringles packaging is one of its most attractive features. The resealable lid allows snackers to enjoy the chips at their own pace while keeping them fresh between servings. Unlike traditional chip bags that often trap excess air and lead to crushed chips, the rigid canister provides a level of protection that helps maintain the product's quality. The success of Pringles is not only due to the meticulous manufacturing process, but also to the brand's ability to continually innovate. Over the years, new flavors and limited edition varieties have been introduced to cater to different tastes and cultural preferences. Research and development teams work to create unique seasoning blends and textures that keep consumers engaged with the brand. In some cases, local flavors are developed exclusively for specific markets, adding an element of regional customization. With the fully sealed and labeled Pringles cans ready for shipment, the final step in the manufacturing process involves distribution and logistics. Once the pallets of Pringles leave the factory, they are sent to distribution centers where they are sorted based on destination. From here, they are shipped to retail locations around the world, including supermarkets, convenience stores, vending machines, and online retailers. One of the key advantages of Pringles' packaging is its durability. Unlike traditional potato chips that are shipped in large bags, prone to air compression and breakage, Pringles' rigid canisters allow for efficient stacking and transport without excessive damage. This means fewer chips are wasted due to breakage during shipping, making the product more cost-effective and reducing food waste. At the retail level, Pringles cans are often displayed in neat, vertical arrangements on shelves, taking advantage of their cylindrical shape. This design not only protects the chips, but also maximizes shelf space compared to bulky chip bags. Supermarkets and convenience stores follow specific stocking guidelines to ensure that Pringles cans remain undamaged and easily accessible to customers. Once purchased, consumers benefit from the resealable can, which keeps the chips fresh longer than traditional bags. Unlike conventional chip bags that often allow air to seep in after opening, leading to stale chips, Pringles' airtight design helps maintain their signature crunch over multiple servings. This has been a significant selling point for the brand and one of the reasons for its continued popularity. Beyond the production process, the Pringles brand continues to evolve. The company regularly develops new flavors, incorporating regional tastes and limited edition releases to cater to different markets. Flavors such as wasabi, pizza, and even dessert-inspired varieties have been introduced over the years, keeping the brand relevant and exciting for consumers. In recent years, sustainability has become a growing concern, leading to efforts to improve the recyclability of Pringles packaging. While the multi-material composition of the can presents challenges for recycling, Pringles manufacturers are exploring alternative packaging solutions that reduce environmental impact while maintaining product integrity. As technology advances, the future of Pringles manufacturing may include even greater automation, improved energy efficiency, and smarter quality control systems. Artificial intelligence and machine learning could further refine production, ensuring even higher consistency in shape, flavor, and texture. Additionally, new ingredients and production techniques could be developed to create healthier or more sustainable variations of Pringles. The journey of a Lay's potato chip begins long before it reaches the factory. It starts in carefully selected farms, where high-quality potatoes are cultivated under strict agricultural standards. Lay's manufacturers work closely with farmers to ensure that only the best potato varieties are used, focusing on those with the right balance of starch and moisture. This is crucial because the composition of the potato determines how well it crisps during frying and how it absorbs seasoning. The selected varieties are chosen for their ability to produce a light, crunchy texture while maintaining the signature taste that has made Lay's a household name. The potatoes are grown in rich, fertile soil, monitored throughout the growing season to ensure optimal size, shape, and starch content. Farmers pay close attention to irrigation, pest control, and harvesting schedules to meet the brand's high standards. When the potatoes reach the perfect stage of maturity, they are harvested using specialized machinery designed to minimize bruising and damage. The harvested potatoes are loaded into large trucks and transported to Lay's production facilities, where the real transformation begins. Upon arrival at the factory, the potatoes undergo an initial inspection to check for quality, size, and any visible defects. Automated sorting machines and human inspectors work together to identify and remove any potatoes that do not meet the necessary standards. The goal is to ensure that every potato entering the production line will contribute to the consistent, high-quality chips that consumers expect. The selected potatoes are then stored in climate-controlled environments to maintain their freshness until they are ready to be processed. Before they can be turned into chips, the potatoes must be thoroughly cleaned. They pass through high-powered washing systems that remove dirt, pesticides, and any residual soil from the harvesting process. This step is crucial, as even tiny impurities could affect the taste and texture of the final product. The cleaning process uses jets of water and rotating brushes that scrub the potatoes without damaging their structure. After washing, the potatoes move along a conveyor belt toward the peeling station. Peeling is an essential step in ensuring a smooth and uniform surface for slicing. Large industrial peeling machines use abrasion or steam to remove the skin efficiently while preserving as much of the potato as possible. The peeling method used depends on the specific facility, but both techniques are designed to be fast and effective, ensuring that the potatoes retain their natural integrity. Any residual skin is removed by high-pressure water sprays before the potatoes move to the next phase of production. With the potatoes now clean and peeled, they are ready for slicing. The slicing process is one of the most critical steps in determining the texture and crispness of the final chip. The potatoes are fed into high-speed rotary slicers equipped with precision-engineered blades. These blades cut the potatoes into uniformly thin slices, ensuring that each chip cooks evenly. The thickness of the slices varies depending on the type of Lay's chip being produced, whether it's classic, wavy, or kettle cooked. The precision of the slicing process is carefully monitored, as even slight variations in thickness can affect the frying process and overall quality. Once sliced, the potato pieces undergo another quick rinse to remove excess surface starch. This helps prevent the chips from sticking together during frying and contributes to the signature crisp texture. The slices then move through an automated dewatering system, where excess moisture is removed before they enter the frying stage. proper moisture removal is essential, as too much water content could interfere with the frying process and create inconsistencies in texture. At this point, the sliced and dried potatoes are prepared for frying. The frying process is meticulously controlled to ensure that every chip reaches the perfect level of crispness. Conveyor belts carry the slices toward massive industrial fryers filled with hot oil. The oil temperature is carefully maintained to ensure consistent cooking, and the frying time is precisely measured to achieve the ideal golden brown color. The type of oil used varies depending on the region and product line, but it is always selected for its ability to enhance the flavor and texture of the chips while meeting health and safety standards. As the potato slices enter the fryer, they begin to bubble and sizzle, their moisture rapidly evaporating as they absorb just the right amount of oil. This transformation is what gives Lay's chips their signature crunch. The frying process is closely monitored by sensors and quality control specialists, ensuring that each batch meets the company's strict standards. The duration of frying varies depending on the type of chip, but every second counts in achieving the perfect crispness. The chips continue their journey along the production line, still hot from the fryer. At this stage, they are carefully drained of excess oil using advanced drying techniques. This step is crucial, as too much residual oil could make the chips greasy, while too little could impact their mouthfeel. A fine balance must be maintained to ensure that each chip retains the light, crispy texture that Lay's is known for. With the chips now cooked to perfection, they move forward to the seasoning stage, where their flavor truly comes to life. Lay's offers a wide variety of flavors, from the classic lightly salted to bold, complex seasonings that cater to different tastes and preferences. Each flavor blend is created using a combination of spices, herbs, and other ingredients that have been meticulously tested for balance and intensity. The seasoning process is highly specialized to ensure even distribution, guaranteeing that every chip is coated with the perfect amount of flavor. Before seasoning is applied, the chips pass through a gentle tumbling system that helps prepare them for even coating. This ensures that every chip has an optimal surface for seasoning adherence. A light mist of oil may be added at this stage to help the seasoning stick, ensuring that every bite delivers the intended flavor experience. The seasoning is then evenly sprinkled over the chips using automated dispensers that precisely measure the amount applied. Quality control specialists continuously test and monitor the seasoning levels, ensuring that each batch is consistent. Lay's has developed advanced flavoring systems that use real-time feedback to adjust the seasoning application as needed. This ensures that no chip is under-seasoned or over-seasoned, preserving the product's signature taste. Once the chips have been seasoned to perfection, they continue moving along the production line toward the next stage of the process. The chips must be handled carefully to prevent breakage and ensure they retain their structure as they progress through the factory. The journey is far from over, with several more key steps left before they are ready for packaging and distribution. As the freshly seasoned chips continue moving through the production line, they enter one of the most critical stages of the entire process: quality control. Lay's has built its reputation on delivering chips that are consistent in taste, texture, and appearance. And this is only possible through rigorous inspections at multiple points along the manufacturing process. Each chip must meet exacting standards before it is deemed fit for packaging, so quality control systems are an integral part of the factory's operation. The first stage of quality control involves high-speed cameras and sensors that scan the chips as they pass along the conveyor belt. These cameras are equipped with advanced imaging technology that detects any chips that are misshapen, burnt, undercooked, or broken. If a chip does not meet the specified criteria, it is automatically removed from the production line using precision air jets that quickly and efficiently separate defective chips from the rest. This ensures that only chips of uniform shape, size, and color continue on their journey. Alongside the automated quality control systems, trained inspectors conduct manual checks at various points in the production process. These specialists sample chips from every batch, testing for crunchiness, oil content, seasoning distribution, and overall flavor consistency. Taste tests are regularly performed to ensure that every chip has the signature Lay's flavor profile. If an inconsistency is detected, adjustments can be made immediately to the frying temperature, seasoning application, or oil levels to correct the issue before it affects a large quantity of product. While the chips are still warm, they move along the conveyor belt toward the cooling system. The cooling stage is essential because the chips must be brought down to a stable temperature before they can be packaged. If the chips were packed while still warm, condensation could form inside the packaging, leading to sogginess or loss of crispness. To prevent this, the chips pass through cooling tunnels where controlled air circulation gradually reduces their temperature. This step ensures that when the chips reach the packaging stage, they maintain their light, crunchy texture. Once cooled, the chips approach another crucial phase, sorting and weighing. The production line is equipped with highly sensitive scales that measure precise portions of chips. These automated weighing systems are programmed to dispense an exact amount of chips into each bag, ensuring consistency across all packages. The portioning must be extremely precise to meet regulatory weight standards and ensure that customers receive the correct amount of product. Any deviations in weight trigger an automatic adjustment in the dispensing system. After portioning, the chips are directed into the bagging machines, where specially designed Lay's packaging material awaits them. The bags are made from multi-layered, high-barrier film that helps protect the chips from moisture, light, and oxygen, three factors that can negatively impact their freshness and taste. The packaging is specifically designed to extend shelf life while preserving the signature crunch and flavor. As the chips drop into the open bags, a stream of nitrogen gas is injected into each bag before sealing. This process, known as nitrogen flushing, serves a crucial purpose. By replacing the oxygen inside the bag with nitrogen, the factory prevents oxidation, which can cause the chips to become stale over time. The nitrogen also helps create a cushioning effect inside the bag, preventing the chips from breaking during transportation and handling. The sealed bags are then heat sealed using precision machinery that ensures an airtight closure. Once sealed, the freshly packed bags of Lay's chips move along the conveyor to the final quality control checkpoint. Here, inspectors verify that the bags are sealed properly, that they contain the correct weight, and that there are no issues with the packaging material. Automated sensors scan the bags for any irregularities, such as improper sealing or printing errors on the labels. If any issues are found, the defective bags are removed from the line before they reach distribution. At this point, the bags are ready for bulk packaging. Large robotic arms carefully arrange the individual chip bags into larger cartons or cases, which are then sealed and labeled for shipment. The cases are stacked onto pallets in an optimized configuration to maximize space efficiency in shipping trucks and storage facilities. The pallets are then loaded onto trucks and transported to Lay's distribution centers, where they are sorted based on their destination. While the chips are being prepared for distribution, data is continuously being collected from the production line to track performance and efficiency. Advanced factory management systems monitor every aspect of the manufacturing process, from the amount of raw materials used to the speed of production. This data allows production teams to identify trends, detect potential inefficiencies, and make real-time adjustments to improve overall operations. Lay's chips are manufactured in multiple facilities worldwide, ensuring that they can reach markets across different regions quickly and efficiently. Each factory follows strict food safety guidelines and adheres to regional regulations to maintain high product standards. The factories are designed to operate at peak efficiency while maintaining rigorous hygiene and cleanliness protocols. Workers in the facility adhere to strict sanitation procedures, including wearing protective clothing, gloves, and hairnets to prevent contamination. Even though the chips have left the factory and are on their way to retailers, the process does not stop there. Lay's has extensive logistics networks that ensure a steady supply of chips to stores and vending machines worldwide. Once the shipments arrive at retail locations, store employees follow best practices for stocking the product, making sure that older batches are sold first while newer shipments are placed behind them to maintain freshness. Lay's packaging is also designed for high visibility on store shelves, making it easy for customers to recognize their favorite flavors at a glance. The branding and design of the bags play a crucial role in marketing, with vibrant colors and flavor indicators clearly displayed. The bags are designed not only to protect the chips, but also to appeal to consumers through enticing imagery and messaging that highlights the quality and taste of the product. The popularity of Lay's chips has led to ongoing innovation in flavors, textures, and packaging options. Consumer feedback plays a major role in shaping new product developments, with research and development teams continuously testing new seasonings and chip varieties. Limited edition flavors and region-specific varieties allow Lay's to cater to different preferences across global markets. This constant evolution keeps the brand fresh and exciting for snack lovers worldwide. With the perfectly seasoned and packaged Lay's chips now prepared for distribution, the process continues beyond the factory walls. While the manufacturing process itself is a highly controlled and precise operation, what happens after the chips leave the factory is just as critical to ensuring that consumers receive a fresh, high-quality product. The logistics and supply chain management of Lay's chips play a crucial role in maintaining their availability across grocery stores, vending machines, and online retailers worldwide. Once the sealed bags are loaded into cartons, they are arranged onto pallets with extreme precision to maximize storage space and minimize movement during transportation. Each carton is labeled with important tracking information, including batch numbers, production dates, and expiration dates, allowing for full traceability. This ensures that if any quality issues arise, specific batches can be quickly identified and recalled if necessary. The pallets are then wrapped securely to prevent shifting during shipment, ensuring that the chips inside remain intact. From the factory, these pallets are transported to Lay's regional distribution centers, where they are sorted based on their intended destination. These distribution hubs act as the central points from which shipments are sent out to retail locations. Temperature and humidity levels inside the warehouses are carefully maintained to ensure that the chips do not absorb excess moisture, which could compromise their crisp texture. At this stage, automated inventory management systems help keep track of shipments, ensuring that stores receive the correct quantities and flavors based on regional demand. As the chips are shipped out to grocery stores, convenience stores, gas stations, and other retail locations, the logistics team continuously monitors their movement. The goal is to minimize the time it takes for a freshly produced bag of chips to reach the shelves, preserving the crunch and flavor that customers expect. Lay's supply chain is designed for efficiency, with trucks following optimized routes to deliver products as quickly as possible. In some cases, chips that are produced in the morning can be on store shelves by the afternoon in nearby regions. At retail locations, store employees are trained to handle Lay's chips carefully during stocking. The lightweight nature of the packaging means that the bags can be susceptible to compression if not stacked correctly. Retailers follow strict guidelines to ensure that chips are displayed properly with newer shipments placed behind older stock to maintain freshness. In vending machines, the placement of Lay's chips is also optimized to prevent excessive movement that could lead to breakage. The careful handling of the product at every stage is what ensures that customers receive whole, unbroken chips when they open a bag. The journey of Lay's chips does not stop at store shelves. Consumer feedback plays a vital role in shaping future production decisions. Lay's has dedicated teams that analyze purchasing trends, customer reviews, and market demands to determine which flavors and varieties are most popular. This data influences everything from production volume to regional flavor innovations, ensuring that Lay's continues to evolve with consumer preferences. In some cases, limited edition flavors are introduced based on feedback, with certain varieties becoming permanent offerings if they prove successful. As technology advances, Lay's continues to refine its production methods to improve efficiency, reduce waste, and enhance sustainability. One of the major challenges in large-scale snack production is minimizing the environmental impact of operations. To address this, Lay's has implemented initiatives to optimize energy usage in factories, improve water conservation during potato processing, and explore more sustainable packaging solutions. One of the key sustainability efforts involves reducing food waste during production. While some defective chips are removed during quality control, they are not simply discarded. Instead, these chips are often repurposed as animal feed or converted into biofuel, ensuring that as little as possible goes to waste. Additionally, potato scraps from the peeling and slicing process are collected and used for other food products or composting. The use of sustainable farming practices is also a priority for Lay's suppliers. Many of the farms that provide potatoes for Lay's have adopted eco-friendly techniques such as crop rotation, reduced pesticide usage, and precision irrigation to minimize water consumption. By working closely with farmers, Lay's ensures that its supply chain remains both environmentally responsible and efficient. Packaging innovation is another area of focus for Lay's as it looks for ways to make its chip bags more eco-friendly. Traditional chip packaging is made from multi-layered plastic film, which is designed to protect the chips from moisture and air exposure. However, the complex nature of this material makes it difficult to recycle. Lay's has been researching alternative packaging solutions that maintain freshness while reducing plastic waste. Some markets have already seen the introduction of biodegradable or recyclable chip bags, with further developments expected in the future. Automation and artificial intelligence are also playing an increasing role in Lay's production process. Advanced AI-driven quality control systems are being used to detect imperfections with greater accuracy than ever before. These systems can analyze thousands of chips per second, ensuring that every batch meets the highest standards. Additionally, robotic automation is improving efficiency in packaging and palletizing, allowing for faster and more precise handling of products. Beyond production, Lay's continues to engage with consumers through marketing, advertising, and promotions. The brand regularly collaborates with chefs, influencers, and food scientists to introduce new flavors and snack innovations. Limited edition seasonal flavors, cross-cultural fusion varieties, and unique textures like extra crispy or extra flavored chips keep the product line dynamic and exciting for customers. One of the most intriguing aspects of Lay's chips is how different regions have their own exclusive flavors, reflecting the local tastes and culinary preferences of different cultures. In Asia, flavors such as seaweed and spicy hot pot are popular, while in North America, barbecue and sour cream and onion remain among the best sellers. Europe has its own set of unique offerings, including flavors inspired by traditional cheeses and herbs. The ability to adapt to different markets while maintaining the core essence of Lay's chips is what has helped the brand maintain its global appeal. At its core, The production of Lay's chips is a blend of science, technology, and tradition. The balance between maintaining the classic quality that customers expect while continuously innovating is what keeps Lay's at the forefront of the snack industry. From the careful selection of potatoes to the high-speed frying process, precise seasoning application, and advanced packaging techniques, every step is optimized to ensure consistency, flavor, and crunch in every bite. The cycle of chip production never truly stops. Even as one batch is being transported to stores, another is already being prepared in the factory. The efficiency of the Lay's production process ensures that there is always a fresh supply of chips available for consumers. The combination of high-tech manufacturing, sustainability initiatives, and a deep understanding of consumer preferences keeps Lay's chips at the top of the snack food market, continuously evolving to meet the changing tastes and expectations of snack lovers around the world.